All right. So let's get started with the webinar. First of all, like always, thank you all for joining in, especially the live participants for staying up early or late to see us live. We really appreciate it. Myself, Aman, I'm from India, and I'm the co-founder of Cadme. Okay, I'm an industrial designer like most of you guys, and what I do at the moment is I run Cadme, where we give live training to industrial designers and design professionals all across the globe. We will talk about this later when we are done with the webinar. So before we get started, I would ask you guys to go ahead and download the files so you can check any of our emails that you must have received, and you will find a download file link which will take you to a web page and Google Drive, and you can download the zip file from there. So I'll give you a couple of minutes. I will also share you a temporary link. Just a moment. In the chat, just in case. All right, hey, from India, from Boise, Oregon, Germany, Netherlands, perfect. Austin, Bay Area. Will this be available to rewatch after? Yes, all our webinars are available. You can use the same YouTube link to watch it again, okay? All right, so once we have downloaded the files, okay, hopefully you are all able to download the files. Let me know if anyone is having any difficulty. All right, so our journey starts by observing these really intricate textures that you can find in any audio products, Bluetooth speakers, or car speakers, and you would notice these really cool perforation textures. And I was always curious how these textures could be made, and that is when I realized that I saw a couple of examples as well, that these textures can be easily made in Grasshopper. Now, of course, there are some simple textures which doesn't need a lot of preparation, but there are more complex textures which you can see at the center, where the radius of the circle fades away, or where they follow a specific pattern. All right, so these kinds of textures can be easily made in Grasshopper. So that is our objective in today's webinar. We will learn how to model this iconic Harman Kardon speaker, first in Rhino, then in Grasshopper, and renders in Keyshot. Okay, so what are the steps that we have to follow? We will start first in Rhino. We will create a curves. Based upon the curves, we will generate the surfaces and solids. We will add the buttons and prepare the overall geometry. After that, we will import the top surface into Grasshopper, and there we will apply the texture. So we will learn how to first distribute the frames, then we will learn how to create these rectangles, and then we will change the size of the rectangles based upon some attractor geometry. All right, and we will also learn how to export it to Rhino so that we can remove it from the top casing. All right, and finally we will export it to Keyshot, where we will learn how to create this render. Okay, so on a black background in a dark environment, metallic material, and we will learn how to apply an animation to that environment. Okay, so once you have downloaded the file, you should see the zip folder. So when you unzip it, you will find these 5 files. Okay. All right. So let's start by opening the first file, which is the Rhino file inside the Rhino environment. Let's open the file. All right. So the way I have structured the Rhino file, you can go to the layers, and here you can find all the different steps that we will be going through in this exercise. Okay. So the very first layer is the image and construction lines. So as you can see, I have given a basic dimension for the curves that we need to draw. Okay, so we will have to draw the outer perimeter, the internal perimeter, as well as the side profiles. Okay, so let's go to the next layer called curves. So let me unblock it. So the steps are, we have to blend these two curves, okay, and then blend these two curves, and we have to blend this curve to define the right profile and the bottom profile. All right, so let's turn on the blend curve command. Right, so in order to generate the curve, you would go to curve editing tools. Here you will find the blend curve command. You can also turn on the help menu in Rhino, which automatically updates and tells you how you can use this command. Okay, so let's select the first curve to blend, and then the second curve to blend. And you can see it pops up the blend adjust menu. Let's go to the top view in order to see the object. So you might be a bit far away from the object. All right, so you have to zoom out and pan across. All right, so here we have to define what is the continuity criteria between the two curves. All right, so G0 or positional continuity will ensure positional continuity between this line and this curve. If I set this to tangency, you can see that this curve is now positionally continuous as well as tangent to the line. We can do the same thing on either sides, as you can see. Then there's a higher degree of continuity, which is curvature. So now we are factoring in not just position or tangency, but also the rate of curvature at that exact point. So the higher you go in the continuity criteria, the smoother transition becomes from that line to this curve. So in this example, as you can see, if you set the continuity criteria to G4, we almost get a similar profile of the boundary curve. But if you have to do minor modifications, you can do that by clicking on any of these points and repositioning the points. Now the issue here is that if you select one point and move it, it will only change the position of the points in this side, but not on the other side. All right, so if you want to do symmetrical changes, let's rerun the command and hold the shift key before clicking on a point. This way you can see that the points are moving symmetrically. Alright, so we will do some minor calibrations. You can also turn on the curvature graph, which is going to show you the rate of change in curvature. Alright. Perfect. So once you have defined that curve, let's redo the operation for this curve in a similar way. Use the Shift key, press OK. Once you have defined these two curves, now it's time to define the lateral profile from here to here. So let me rerun the blend curve command. And we will be blending the top line to the vertical line. Okay, so let's go to the right viewport to see what's happening. So what we have to do is, let's go with positional continuity, and in the second edge we will go for tangency. In the first we will go for curvature. Just have to move the point as per requirements. Okay, and you can see we have captured quite precisely the shape of the top profile. Okay, we will do a similar operation for the bottom profile. So we will blend the top profile with this line. Blend this to that, and let's go to the right viewport. Same here. So we will go for tangency on the second edge and curvature on the first edge. So you can move the point. In this case we are not going for symmetry because either ends have different sets of points. Okay, so here you are able to see we get a G2 curvature continuity here. Press OK. Alright, so we have defined the curves. Now, in order to understand why we have used these blend curves rather than just a simple fillet, let's go to the next layer, where we are going to compare this simple fillet that you generally apply when you have to round any corner in Keyshot, sorry, in Rhino. Okay, so here you can see this is a simple fillet. So if I show you the curvature graph, you can see the difference in curvature. So here you have a straight line, and then suddenly you are curving at that exact point. Whereas here you have a straight section which continues and slowly ramps up the curvature. So what this translates into is when you check these surfaces made from these curves, say if you extrude it, right, so you convert them into surfaces, and you run something like EMAP, which is some kind of environment analysis, you can see the reflection that these two geometries will create. So here, as we are changing the curvature abruptly, you will see a sharp highlight, as you can see here. Okay, whereas in this case you will not be able to see a sharp highlight because we are transitioning from the flat region to the curved region on a longer patch, and we are slowly ramping up the curvature. So this is going to create better quality surface, better effect in the product. Okay, especially if your product is made out of glossy material. Alright, so let's go to the next layer, which is basically mirroring these curves. So let me get rid of all of these curves just to show you what are the next steps. And you would mirror this from here using the shift key, and these two from here using the shift key. Right, so here you can see we have all the curves, and you just move this one on this place, which I think is around 13.5 millimeters, 16.5 millimeters. Okay, you have those curves here. Okay, so we have a question: how would you know which type of continuity is the one to use for which curve? The continuity depends upon what are you trying to create. So if for aesthetical parts, glossy parts, you would go at least for G2 curvature continuity. Okay, for mechanical parts you can go for G1, or if your surface has rough texture, you can even go for G1 without any problem. Okay, it's primarily when you're working with the glossy parts you would want to go for G2 and higher. Now in this case we went for G4 because we need more number of control points to capture the shape. Okay, if I would have been able to get the shape using less number of points, I would have used G3 or G2. Okay, but we needed this many points to get that exact shape that we have here on the perimeter. All right, so let's go to the next step, which is converting these curves into surfaces. So let's unlock the next layer. All right, so here we have the perimeter for the top part, and we will be using this for revolving this profile across this rail using this axis. Okay, so for this step we will be using a command called Rail Revolve. Okay, let me show you the help menu. That's the command name, that's the icon, and you basically have a profile, a rail, and an axis. Okay, so let's run the command. It's asking me to select the profile. This is the profile. Let's start with the bottom one. Then it's asking me to select the rail. This is the rail. Then it is asking me to select the axis. This is the axis. And you will notice that it has converted that profile into a surface by revolving it across this rail. Okay, now we will do the same thing for the top edge. So let's rerun the command. Rail Revolve. Surface edge, we will use now the surface as the the first is the profile, then the rail, and then the axis. Okay, so these are the two halves. We will join them together as a single poly surface, but it's still hollow at the bottom, and then we cap it. Okay, perfect. Rail Revolve is better than one rail. No, these are all three different operations. Okay, as we want the profile to maintain a specific orientation to the central axis, we are using Rail Revolve. We cannot sweep one rail. And with sweep two rails, you need the second curve as well, which we don't have in this case. This additional curve that we have generated, this is for Grasshopper later on. Okay, so you will notice that. Perfect. So this is the solid poly surface. Okay, you can check it in EMAP, the quality of the surface that we have made. Okay, so the next step is to convert this closed volume into two halves and shell it out. So the first step would be finding from the right profile the height where we have to cut it out. So I have already drawn that curve for you guys, and you can use the gumball to extrude the line. If you pay attention to this circular dot here, you can drag it from there to generate a surface. Okay, you would run Boolean split to split the solid with the surface. So you have these two halves. Okay, now we have these two halves and we need to shell the structure. So you can use the shell command. Okay, and the thickness that we are providing is 1.6 millimeters. Click on the face that you would like to remove and add the wall. Same here. Okay, make sure always that whenever you apply the solid operations, you end up with a solid poly surface. Okay, so later on, if you would like to 3D print it, or even before 3D printing, more Boolean operations that we have to do, it will only work when these geometries are solid shapes. And at the end, we will add some micro fillets. So let's apply solid fillet of 0.35 millimeters. Okay, on the two edges, bottom as well as the top. Okay, so that's the end result. You can check it under EMAP. Questions? I hope you were all able to download the files. The micro fillets are defined by running the fillet command, defining the radius, which is 0.35 millimeters, and selecting the edge. Yes, the Mac navigation is a bit different, although you can always execute the same command by repeating it in the command bar. So for example, if you want to do Boolean split, so Boolean split is Boolean space underscore Boolean split. Okay, you can see the name of the command here. Or if you want to shell the structure, the command is called shell. Okay, if you want to apply fillet, it's called fillet edge. Okay, extrude the, how to turn on the axis you use to extrude. Yeah, so some of you might not be seeing when you select an object this tool. Okay, so this tool is called the gumball. So if you use Rhino Windows, you will be able to find the gumball here at the bottom part. Okay, so if you turn it on and off, you can toggle the gumball. For Mac users, it will be on the top part around here. Okay, now once we have the solid shape, now let's add the buttons. So let me unlock the next layer. If you want, you can hide the previous layers. Alright, so the buttons are added by defining these profiles. Okay. You're asking if 0.35 is it a standard measurement? What is EMAP? Turn on the gumball. Standard wall thickness. Okay, yeah, 1.6 could be a standard wall thickness depending upon the material that you are trying to manufacture the part from, and depending upon even in the material if you have internal structure, also if you have perforation in this case, so it will totally vary, but that is kind of a general number. So 1 or 2 millimeters, 1.5, 1.65. Alright, so once we have the curves, you can select the curves, and you will notice that when I select one object, it selects all of it together. That is because these curves are grouped. Okay, so let's ungroup it. And we can select these two curves and extrude it using the gumball. Make sure that when you extrude it, you are cutting the shape completely. The same here. Let me extrude it in this axis. This one as well. Alright. And now it's not necessary to make these shapes solid. Okay. However, we will be doing one more step. So it's better we convert these shapes into solid. So you can do that by capping them all together. Cap. Okay. Now once we have the cap, we have two different things to do. The first is we have to create the hole for the button, but we also have to create the button that is within that hole. So what I have done is I have offsetted this geometry. So you can go to solid, offset, and you can provide a minor tolerance gap, let's say 1 millimeter, 0.1 millimeter or 0.2 millimeters. Okay, so here you will notice that you have two geometries, one within the other. Okay, so you will be using the outer one to remove the material from here, and you will be using the inner one to intersect it with that one. Okay, so basically what we are doing here is we will first create holes using this one, Boolean difference. So these ones are the bigger ones, and these ones are the smaller ones. So we want the intersection between this and this shape for the button. So you can go for Boolean intersection. This to this. So can you see it gives us only the button part. Now of course we don't want to delete the input, so let's undo that. Okay, so let's select this to this. Okay, so we have that part. This to this. We have that part. This ones we don't need. This to this and this to this. Okay, so now when you delete it, you are left with the buttons and the holes. And this is the final assembly. So you can just apply minor fillets. Same 0.35. You can double click to select the edges in chain. Okay. Same here with the buttons. So this is the end result. Okay, now let's go to the next step, which is the part about Grasshopper. Let's just say in Rhino 8 you can cut directly with the gumball as well. That's interesting. I think it's called the push-pull workflow or something like that. All right. So for the Grasshopper part, we just need the top surface. Okay. So here, what I will do is I will use the curve that we have generated, and I will get rid of everything except the top face, and then we will split the surface with this curve. Okay, so I have extruded the curve. Let's split this with that. Okay, so what we are doing is we're just isolating this part because that is the part where we have to apply the texture. Okay, so basically here you have the original surface and the trimmed surface overlapping each other. Perfect. So now let's jump into Grasshopper environment. So let's click on this button, or you can write in the command bar Grasshopper, and it's gonna pop up this floating window on top of the Grasshopper window, sorry, Rhino window. Okay, so generally when I'm working with Grasshopper, I would use half of the screen for Grasshopper and the other half for Rhino. Okay, now let's drag and drop the file that we have in the second step, which is the Grasshopper file, inside the Grasshopper environment. Guess you just drag and drop it here, and it's gonna open this file. Let me know if all of you were able to open the Grasshopper file. Now I have divided it in two sections, so people who have used Grasshopper before, you can try and follow it from the top part, and those who are starting with Grasshopper, you can follow from the bottom part where you have all the nodes. You just have to do the connections. Okay, so basically what we are doing here, let me show you by hiding these geometries, is to figure out how this texture is made first. So if you follow the texture in one direction, let's say from here to here, that is the orientation of the texture in this direction. Okay, now the texture in the other direction is, if I have to create the pattern, I'll just take the center point of the capsule and follow it along here. Okay, so you will notice that we have the texture following in this direction and in the other direction. Okay, that means we have to create contours, okay, cross sections in this direction by some spacing. Now the way the contour command works is you have to give a perpendicular vector to it. So I have to rotate it 90 degrees. And here as well, I have to rotate it 90 degrees in order to get a contour perpendicular to it. Now the gap between these two curves is around 60 degrees, as you can see here, the bottom. Okay, so with those data, let's dive in the Grasshopper workflow. All right, I will also turn on a tool called bifocals, which is gonna draw the name of the component on top. So I have imported the surface. Did you draw those lines? No, you don't have to draw anything. You can delete it. I was just showing you how the lines were distributed. Okay, so for the contour command, you need the shape that you would like to contour. You need a point from where the contour begins. Okay, so I have added a point here. Okay, and the reason for that is, as you can see, one of the texture is passing through this point. So I'm just taking a uniform distance from the center and providing it there. So that is why I'm using a point here. But you can change it as per your requirement. And the direction. So as I told you, if you want contours in this direction, you have to create the curve in the perpendicular direction. Okay, so I have rotated it 90 degrees. Okay, and the gap between the contours is 1.85. As you can see, you are able to change the gap between the contours. And now we have all the curves intersecting the shape. Questions? Alright, so once we have drawn the contours, we have to draw the contours in the opposite direction. As I told you, we are going to be using the same geometry that we have to contour. Okay, the same surface. So let me rerun the contour command. Same geometry. You can just copy it, or you can even use the same one as per your requirement. Same point. The direction, however, is gonna be rotated 90 degrees. So you can either copy the curve. Can we make the similar textures in Rhino? You can not make it in Rhino because probably you are gonna be able to divide the surface like that using the contour command. But if you look at the perforations, which change the size as per the distance from the edge, you cannot do it in Rhino. Okay, you need some kind of logic to change the size based upon certain distance. Okay, so you can't do this just in Rhino. You have to use Rhino and Grasshopper. Now for the contour in the other direction, you just copy this and rotate it 60 degrees. Okay, so you can import that curve in Grasshopper as the distance, a direction, and for the distance, I think in this case is 3.7. Okay, and you can see here how we are able to redo the intersection between the two curves. Now for people who are following this part, let me redo it here. Shape, point, direction, distance. Okay, and for the bottom, shape, point. Now what I have done is, rather than rotating it manually in Rhino, I'm rotating it in Grasshopper. Now remember that whenever you're providing an angle in Grasshopper, it's always in radians. So if you're rotating it 60 degrees, you need to convert degrees into radians. Okay, and this is the direction, this is the distance. So that's the two sets of contour curves. Okay, the next step is to perform intersection between these two curves to find these points. So we want to intersect all the curves with all the other curves. So we have to consider all of them in the same operation, and you do that by flattening the tree. Okay. So flattening the tree will put all the curves in a single list. In this case as well, in a single list. Before that, Contour will generate a lot of smaller lists. After flattening, it will put all the curves in a single list. And in order to perform the intersection, you go to Intersection, Physical, Multiple Curves. So you connect all the curves together. You can use the Shift key to add multiple cables in the same connection. Because if you just connect it as it is, you will see the other cable dislodges. So you would use Shift key to add multiple cables. Now it's really important when you're working in Grasshopper to hide the previous steps. So let's select all the nodes except the last one. Press the middle mouse button and hide the previous steps. Okay. So as you can see, we have created a grid of points that you can see from this angle and from the other angle. They are following the pattern. Okay, I guess you were able to follow until this part. Let me know if anyone is having any difficulty. All right, now once we have the points, we need to create planes on these points. Okay, so let me create a plane oriented in the X and Y direction. So point is basically a coordinate in 3D space, and a plane is a coordinate plus an orientation. Okay, so as these textures are rotated 60 degrees, as you can see here, I think I have to draw it in this way. Okay, they're rotated 60 degrees. I have to rotate these planes as well 60 degrees. Okay, so let's rotate these planes using itself as the plane for rotation, because we want to rotate it in the same plane. Okay, and the angle is going to be 60 degrees. Now again, if you just connect the angle as it is, you can see it doesn't rotate to 60 degrees. If you want to rotate it to 60 degrees, you convert degrees into radians. Okay. All right, so let me hide the rest. Hank, try to, I don't know if you're able to, you can also probably carry on from this part. Just hide and unhide the steps. Okay, at least you're able to see what's happening. All right. So here you can see we are able to rotate the planes 60 degrees. So whatever we generate now will be oriented in that direction. Okay, so once we have the planes in place, we will now create rectangles on these planes. Rectangles on all of these planes. You can hide the previous steps. Okay, and in order to define the dimensions of each rectangle, we need to provide the values here. for X and for Y. Okay, now you will notice that the rectangle component accepts one number and it's growing the rectangle from the center of the plane towards this side, okay, by 0.7 units. However, we want that the rectangle grows from the center of the plane symmetrically on either sides. Okay, so when you want a symmetrical rectangle, instead of giving a single digit, you have to give it a domain. So you have to tell it that the rectangle goes from this to that, rather than 0 to 0.70. Right, so let's create a domain component. So you tell it starts from this value and goes to the other way. So the other way is going to be negative. All right, so whatever value you have here, you want to convert it into negative. So you can use a negative node to convert 0.7 to negative 0.7. Okay, so you are creating an instruction which goes from 0.7 to negative 0.7. All right, so now you will notice that we are changing the dimension of the rectangle symmetrically on either sides. Okay, I'm not currently I'm not getting any feedback from Grasshopper Design. The curves are already incrusted, so you shouldn't have any problem connecting the geometries. Make sure you have set the correct visibility for the objects, okay? And you're also looking at the correct place. Maybe you're not near the surface where we have the geometry. The easiest way to find it is just select the node, press the middle mouse button, and zoom in to the Grasshopper object. Okay, this zoom is similar to what you do in Rhino by pressing this button, zoom selected. Okay, all right, so here you can see we have defined the Y direction. Now we have to define the X direction. Okay, so you can literally copy this entire part and define the X direction. And here you can change the size. You will notice that the number slider doesn't go beyond 1 unit by default. So you can create a new number slider, or you can edit this one by double clicking on the name and telling that it can go up till 5 units. Of course, we don't need that much amount, so I think it's 1.75. Okay, so until this part, you could have technically made it in Rhino. Okay, it's creating contours and copying an array of points, array of rectangles of fixed dimension on these points. Okay, that could have been easily done in Rhino. However, the next step that we are going to do, you will have to do it in Grasshopper. Okay. All right, so we have created the contours, intersected the contours, generated the planes, rotated the planes, generated the rectangles, okay, in symmetrical manner. All right, now the next step is we actually don't need a fixed number for the width. Okay, the width should be 1.75, let's say, at max, but it should reduce as you approach the boundary to a lower number, almost 2.45. Okay, so rather than giving it a fixed number for all the rectangles, we have to provide one value for one rectangle. So for 1106 rectangles, we need 1106 values. Okay, so in order to calculate those values, let me show you an approach where we will be performing an attractor workflow. Okay, so the first thing that you need to do is determine which geometry is it that we will use to change the dimension based upon the distance. So in this case, the geometry that we will use to change the dimension based upon the distance is the boundary of this surface. Okay, so you can either duplicate the boundary in Rhino using this tool called duplicate face boundary. Okay, or you can extract the boundary by connecting a curve node. Okay, either would do the job. Alright, so once we have extracted the curve from the original poly surface, our surface in this case, we will find the distance between this curve and this point, and this point, and this point, right? So we will calculate what is the distance between these points and the curve. So in order to find the distance between the curve and these points or frames, we will be using a tool called curve closest point. This is the curve that we would like to evaluate. These are the points that we will like to pull to the curve. So you will notice that all of these points are now being pulled to the curve. Okay, so a point that is farther away is going to give us a different distance than a point that is closer to the curve, right? So this curve would be, or this point would be around, let's say 5 millimeters, but this one would be 42 millimeters. All right, so depending upon the distance from the frame to the curve, we get different distance values. Now, rather than having a fixed number for the symmetrical rectangle, we can use the distance value for the rectangle size. And you will notice that the rectangle is changing the size as you go away from the center. But if you use the raw number, that is a lot of dimension for the rectangle. All right, so we have to use a distance value that is lower than that. So let's see. We can easily multiply. Can I use divide curve instead of intersecting curve? So that's a good question, Rohan. You can technically use divide curve, but in this case, you want the geometries to follow on a specific height, and the divide curve command needs the total length of the curve. And if you see the contour lines, all the contours have different length, so you have to divide them precisely by a certain amount so that the frames fall exactly on these places. So it's a lot more easy to draw the curves and intersect it exactly where you need, rather than relying upon the divide command. All right. So here we have the distance that the points had to travel to be pulled to the curve. Now I can use the distance value as the raw number, or I can multiply it to reduce the value proportionately. So if I reduce this number, you will notice that we are getting closer to that effect. Okay. So rather than using, let's say 50 millimeters, if I divide it by 0.1, now I'm using 5 millimeters. So you are proportionately reducing the distance in order to control the rectangle size. Okay. I'm not sure if it's working for all of you. All right. Now, the issue with this workflow is that depending upon how much value you put here, the maximum and the minimum size of the rectangle would vary. So you don't have a control over the maximum and the minimum size. So this is where we will be performing an important operation called remapping. Okay, so remap number, what it basically does is that, let's say you have a set of numbers, okay, starting from 5 millimeters till 74 millimeters and everything in between. Whereas you want to remap it between 2 millimeters and 10 millimeters. Okay, so this is what you have, this is what you want. So the remap component exactly compresses this number to this, that number to this, and everything in between accordingly. Okay, that's what remap does. So we have a lot of distance values, and they go from some number to some number. The easiest way to know what is the minimum and maximum of a list is by connecting a tool called bounds. Okay, so here if you check the distance goes all the way from 0.01 till 20 something, 30 something. Okay, but if I connect this tool here, I know what is the lowest number and the highest number of the entire list of 1100 values. Okay, so that is our source. Okay, so this is what we have and this is what we want. Now I just use a random number, but you can define here the correct values. Okay, so just like before, you create a lower number that you need, which is gonna be same as the width, 0.5, 0.45, and a higher number, let's say 2.0. So at the output, all the numbers that you will receive will be between those two numbers always. So we have taken some arbitrary set of numbers and we have squeezed it between these two values. That's what remap is doing. Okay, so that we have now a better control over the minimum rectangle length and the maximum rectangle length. Okay, so none of the rectangles length would be less than 0.45 or larger than 0.2. You can also change it here. Okay, so this is the end result. And at the end you can add a fillet to the rectangles. Just add any number that is large enough and you will get the rounded corners. Okay, Now if you're kind of behind in the steps, don't worry, you can go to the down part and you can turn on the visibility of these different layers. Okay, so you can see that we have done the same steps here, rotated the planes, performed the same remap, and at the end we have the rectangles. Now the next steps that I have done, you don't have to do it, but I'm just going to explain it to you quickly. So we have a set of curve that we have used to define the boundary where we don't want the texture. Okay. Then I would have extruded it, capped it, and then we are intersecting these curves with these solid. And it gives us the outside curves. So it has removed all the curves within that solid, as you can see here. This part is basically finding the naked edges and joining it together. So as you can see, when you do the trimming, it is creating open curves, but with this approach I'm just joining the end points with a straight line and joining everything together to create a closed curve. Then finally we are moving it up and then extruding it down by -10 units. Alright, so if you are in your Grasshopper canvas, you can get to this part, make this part visible, okay, and you need to convert this geometry now into a Rhino geometry. Okay, so in order to do that, you right click on it, on the component, and there is this option called bake. Okay, it's better you use the right click option rather than the middle button option. Okay, because when you right click and bake, you're able to group the objects together. So let's group, bake it, and here you have the extrusions. Okay, now there is a fixed gap between all the steps. I think it's 200 units, so you can move it by 200 units, and then you can perform a Boolean difference between this using these. A lot of times you will notice that I'm performing Boolean operations in Rhino, and that's a common approach because Grasshopper is quite slow when it comes to Boolean operations using the native components. Alright. Okay, so you can leave it for a couple of seconds and it should give you the final result, as you can see here. Questions? Let's see. Is it possible to do multiple attractors? Yes, it is possible, but you require a bit more preparation for that. Missed the Boolean when you shifted us to the final bake. So once you bake the object, group it, and you move it by 200 units. Okay, so you click on the gumball and you can move it by a fixed amount, 200 units. Okay, the arrows you can either drag it, but if you want a fixed value, click on it, and then variable contour space. Yes, you can also do that. So let me show you just by this part. Okay. So for a variable contour space, what you need to do is, rather than having a fixed value, you have to have different values. So let me see if I can do it easily. I think it's gonna be a lot easier if you do it in a different way. Yeah, within the contour command, it doesn't accept variables. So it's basically creating new sets of contours. We don't want that. So yeah, basically, if you want to do variable contours, you draw one line. Let's see here. Let me import it in Grasshopper. And I will project that line on this B-wrap. Okay, that's the curve. Okay, and then what you can do is move this curve in the direction that you need. That could be perpendicular to that. Okay, just for the vector, but you can define it in X, Y, and Z, and you can create a series of numbers. So you can define what is the increment, and there is a tool called mass addition where you can do a partial result. So as you can see, it grows by adding the previous number to it. So you can use it for defining a variable distance. To convert this to vector, okay, so there are different ways you can do it. Okay. Missed the boolean menu shifted variable. Can you show me your mesh options? I'm asking for a surface quality. Is it possible to use graph mapper to make variable contours? The contour command itself is locked to a single number, the single space. You have to use some kind of array where you are defining different gaps, and then you project it to the geometry. Mesh options, you mean the surface mesh? You can go to document properties, and in the mesh setting, I'm just using the default jagged and faster option. Okay, for talking about graph mapper, if you go to the very last section, we have also created a variation, but using a graph mapper here. So let me disconnect it. And here, if you modify the graph, you're able to change the pattern fading effect, as you can see here. Okay, you can also right click on the graph and choose different options. Can you map the surface curves to the normal? Yes, you can also do that, but again, you need a bit more time and preparation for applying the normal perforation for the texture. Alright, so once we have defined the final texture, you can unlock the last layer, which is the final assembly that you will find here. Okay, so we have all the different parts that we will need for the render. Alright, so let's go to the next part where we will generate the renders. So in the file section you will find the third file, which is the Rhino file that you need for render, but I have already imported in Keyshot, so let's open the fourth file. Okay, so when you open the file you should be able to see this geometry. Let me know if all of you are able to open the Keyshot file. No worries, Timothy. Thanks for joining. How much to fillet the holes? You can technically do that. In Grasshopper you have an option to select the edges and you can apply bulk fillet. Alright, so once we have imported the geometry, first let's see what do we have here. We have the top casing, we have another internal surface that we will use for speaker mesh, the AUX and USB-C buttons, the base geometry, the text at the bottom, and then the text at the top. Okay, now the first thing that I will do is select the top casing and enter its material settings. You can do that by double clicking on it, and I will convert it into a metallic material. Okay, you can change the color, you can make it golden, or you can change the color to white or black. Alright, now before we correct the materials for the rest of the geometry, let's see and configure the environment, because lighting is really important when you're creating a render. So let's go to the environment setting. So this is the startup environment. We're not going to use that. I have created a new environment, a blank environment. Okay, so what you have to do in your new environment is go to HDRI setting. The first thing that we have to do is change the background to black color, so there is nothing in the environment. Then we add a pin light by clicking on this button, and you will notice that it is adding a light source in our environment. Okay, so when you add a new pin light, you will also notice this button pop up, which is asking whether you want to click to position the pin light on the geometry. So wherever you click, you will notice that the pin light is positioning itself normal to the place where you're clicking. Alright, and press done. Now the metallic geometry that we have at the top is glossy, so if you add a bit of roughness, it will create a more interesting result. As you can see here, because I am adding a bit of roughness. So you can go to the top camera and start adding more lights. So I'm going to add one light which is pointing around here, another one pointing around here, third one, you can use this button to set the highlights. And a fourth one for here. Okay. All right. Now, once you have defined the lightings, let me hide the top casing and focus on the speaker mesh. Okay, so this is also made out of metallic part, so let's change it to metal, gray metal. Can add a bit of roughness. Okay, now rather than a solid geometry, we will add some changes. So let's open the material graph for that shape, and we will add a mesh texture. Okay, so the mesh texture will let you add opacity map to the speaker mesh. Okay, so let's connect it to opacity. It's basically a black and white map, so wherever it's black, you are seeing through the material. You can go to shape and pattern, and you can increase or decrease the circle size. Okay, as per your requirement. All right, so once you have defined all these material settings, you can directly go to this layer. So you hide the start layer and turn on the finished layer. So this is the end result. You can check, we have the top casing, we have the mesh, the internal parts, and the other settings here. In Mac, when you enter the Keyshot interface, you double click on a material, and here you will find the material graph button. If you don't see the material graph button, you probably don't have the education version or the pro version. Okay, it is only available on the pro version. Okay, and you also have the other environment that we will use for the animation. All right, so once you have defined the lighting material setting, now for the animation, okay, you can see I have already added one animation here. Okay, so let me repeat how you can add an animation in Keyshot for the environment. You click on Animation Wizard after turning on the animation interface, and here within the environment animation, you rotate the environment. You rotate this environment, and you define in how much time, let's say in 3 seconds, how much you are rotating. Let's say 360 degrees, complete rotation, and press finish. And you will notice that now the environment is rotating 360 degrees. Okay, so this is the technique that I used for rendering this effect. Okay. So when you want to rotate in HDRI, you use the HDRI rotation for animation here. Alright, and in order to render the final file, you go to the render tab. Okay, it's gonna pop up the render window. Okay, and here you go to the animation tab, select the resolution, select the folder. I will recommend you guys to also save the frames because Keyshot is prone to crashing. Okay. Alright, so once you have defined where you would like to save the files, a really important setting is the quality setting. Okay, so you will always be rendering in maximum samples. Now, how do you determine what is the number of samples you need for the render? Well, in order to find what is the quality that you need for rendering, you have to press the letter H to visualize the heads-up display. Okay, view heads-up display. Okay, then here you will find the number of samples that is being calculated as you let it run through. Okay, so there are a couple of questions. I'll get back to you just a moment. Now be careful because when you're rendering in GPU, you can see it goes through the samples quite faster, and when you're rendering in CPU, the samples increases slower. Okay, so you can render faster in GPU, but also the two samples are not correlated. Okay, so you can have a pretty decent quality in 200 samples in CPU, and in order to get the same quality, you probably need 600, 700 samples in GPU. Okay, so it doesn't matter whichever mode you're using. Be careful if you're using GPU, calculate how many samples it says here until you see a nice result. So if you want, you can even zoom in. Okay, so by 600 or 800 samples, this is good enough. So when you go to render, and if you're in GPU mode, set that number here. Okay, and if you're in CPU mode, okay, do the same step. Just zoom in. It's not necessary to zoom in, but in this case, as we are not changing the camera angle, we don't have depth of field, we can zoom in to inspect closely what should be the sample amount. So let me show you on a corner. Okay, so you will wait until you have resolved all the noises in the image. By 70-80 samples, this is good enough. All right, so you can set that number here and then press render. Now some of you are asking, if it crashes, what is the suggested render hashtag? I think you're asking about this number. That is when you set a name and then you render, so it will append this name next to the render so that you don't override an existing file. Someone asked, if it crashes, would it be able to continue the render without starting over? it will not automatically start from where you finished. But if you export the frames, let me just show you quickly. If you export all the frames, what you can do then, so this is how you will be exporting all the frames. All right. So if you render and your render crashes at, let's say, frame 29, you will have 29 frames. So you can come back to Keyshot when you restart it, and then you can say, well, start from frame number 28 or 29. So you can continue from that frame rather than redoing these frames one more time. Okay. Do we need settings for GPU and CPU? You don't need different settings. It's just that either mode works differently in the way they're calculating the samples. So make sure you're in the correct mode when you're defining the quality here. What is the difference between EMAP and Zebra? So EMAP is a visual analysis. You're just looking at it by reflecting a metallic kind of environment around the geometry, whereas Zebra is going to give you an accurate representation of the two. So just to show you an example, let me see. Okay, that is an extrusion. So in EMAP, I'm looking at the surface using this metallic or any other of these HDRIs applied to the geometry. It doesn't give me an accurate representation of what's happening. A Zebra, on the other hand, can tell me a lot about the surface. So if I see that the Zebra is not continuing smoothly, these two geometries are tangentially continuous, not curvature continuous. So Zebra gives you more information about the surface quality. EMAP is just the general look and feel of the surface. All right, so let's go back to Keyshot. Right, so this is how you would be rendering in Keyshot. Tim asks, what is the configuration for my hardware? So I'm using a Legion Pro 7, a laptop from Lenovo. It has a 4080 graphics card for a laptop, and so far it's pretty good. So if you are looking for a new system, probably you can find it on sale. It's worth. Not sponsored. All right, so I guess you are able to follow this far. Nonetheless, you have the recordings of all the things that we have seen so far. Okay. Now, before we address more questions, let me quickly take you through what we do at Academy. And if you have more questions, keep on writing it in the chat and I will address them at the end. So at Academy, we offer live courses to design students and design professionals. So we offer 4 courses at the moment: Rhino, Grasshopper, Texture Workshop, and Keyshot. In Rhino Masterclass, you will be learning how to solid model, fundamentals of NURBS terminology, explore surfaces, how to match continuity, degrees, weight, spans of curves and surfaces, mesh and subd workflow. So you will have a good overview of all the different things that you can do in Rhino, and at the same time develop a solid foundation about NURBS, mesh and subd geometries. Okay. Then we have the Keyshot rendering masterclass. So this is where you would learn how to render products starting from the scratch, how to use materials, how to create your own PBR textures, You will learn how to create physical and HDRI lights, how you can create procedural materials, okay, animations, parts and camera animation. So this is one of the example that we saw on environment animation. All right, how to create multi-layer materials, material graph, utility nodes, etc. Then we have the Grasshopper masterclass. So a lot of people are interested in this course. They always inquire us about this one. So this is designed specifically for anyone who is starting to learn Grasshopper, or they have no idea, they're absolute beginners. So they can get a really good foundation about how Grasshopper works on a fundamental level. Okay, so you will get familiar with data tree, list management, geometry hierarchy, parametric modeling. Okay, and you will also learn the basics of attractor workflow, mesh and subdue workflow inside Grasshopper, how to perform solid operations, etc. The texture workshop is a continuation of the Grasshopper masterclass, where you would learn different tricks and tips to create complex parametric textures, and not just create it but also transfer it to your geometry. And all these textures that you see here are created in the NURBS context, keeping in mind design for manufacturing. So you can always take these files and share it with the engineering team so that they can proceed for the manufacturing phase. So this is a variation of the texture that we created, but in this case we have used a lot more advanced techniques that you will be able to do once you learn the advanced texturing workflow. All right, so a lot of people also inquire us that what is the need of learning Grasshopper and Rhino. Well, we have noticed a growing trend in all design companies and studios that a lot of them are moving towards Rhino, because if you compare the pricing of Rhino to other CAD packages, it's quite cheaper. If you take Alias, for example, it can retail all the way from 15,000 euros above, right? And other CAD package, you have subscription, and Rhino is like for perpetuity and it's not that expensive. And then you throw Grasshopper to the mix, it opens a lot of possibilities. Okay, so a lot of companies like Apple, Logitech, BSH, they have their own parametric or computational design division, and they always require anyone applying for the job to know Grasshopper and Rhino. Okay, so before we close down, we would like to share some of the projects that were done by our students from past classes. So you can check in our portfolio section on our webpage. So these are all the different submission. So once the students finish the classes, they have 45 days to submit a project. And these are past submissions from our students. Okay, so we have been conducting the classes for almost 3 years, and each month we have different groups, 3 or 4 groups, and we are joined by design professionals and students from different companies, freelancers, universities, etc. We also offer team training. So if you're coming from a company or a team, you are 4 or 5 people or more, you can also request a team training module where we can tailor the classes as per your requirement. So we will add content as per your requirement and also as per your schedule. Okay, if you are interested in knowing the dates, price, and other information, you can sign it up in our webpage. And you should tag us whenever you are creating any workflow so that we can share it with our social handles and give your portfolio a boost. Okay, so if you share on LinkedIn, Instagram, or Behance, you can find us on by searching Academy or academy.xyz, and we will reshare it with our audience. All right, so thank you all for joining. If you guys have any more questions, I will check on the chat. All right, so thanks again. Thank you all. So someone asked a class A surface course on Rhino. We haven't created yet the class A surface. In the Rhino masterclass, we do talk about the initial steps that you require for a class A surface modeling. Okay, so you will be learning how to model this AirPod case using the class A surface workflow. So single span, splitting as little as possible, matching the surface edge continuity, etc. How do you find hand pictures in Pinterest? What do you mean by hand pictures? You mean these pictures that you're seeing here? These are my hands. So I take pictures, we edit it in Photoshop, so that's the end result that you see. Okay, Diego, thank you very much for joining. Chayatom, okay, but yeah, check on Unsplash Pinterest, maybe you can find it there. Thanks for the time. Is there going to be another webinar? If so, can you give us some preview? Michelle, we will be having another webinar, but probably in a couple of months. Okay, but again, if you guys are interested in learning anything specific, you can mention in the comment of this webinar so that we have an idea of what to do in the next one. All right, Hank, thank you very much for joining. Sasha, okay, yeah, thanks for clarifying. These are pictures from our SLS prints. Rohan, thanks for joining, and thanks for also attending the Grasshopper Masterclass. Proper layout method that good for general design process. I always mess layer up along the way of modeling process, especially after a few design iterations. Again, this is something that you have to figure out, like what works best for you. But in my case, what I generally do is I would, let me see. So what I would do is, let's say whenever I have to model a complex geometry, I will model it in step-by-step format, so that whenever I mess up something, I can go back to the previous steps and recover the geometry from there. Okay, yes, it makes the file a bit heavier, but in the long run it saves me a lot of unnecessary challenges. Okay, so here you can see the entire set of steps are like you work on a part. Once you make certain progress, you copy it, move it by a fixed distance, and then do the next steps. Okay, you work on it, copy it, and the next step. And you can maybe hide the previous steps if you don't want to see it, or if it's interfering with the viewport. Okay, just take a class, blah, blah, blah. Will you teach sub-D in Grasshopper? Depends, like, yes, we do use sub-D workflow in Grasshopper, but you don't model like the way you model in Rhino. In Rhino, you're actually sculpting the geometry. In Grasshopper, you will learn how to use the sub-D workflow so that you can create any complex texture and bring it to the NURBS world. Okay, so that is what we will be understanding in terms of sub-D in Grasshopper. Thank you, rman.as. No Grasshopper for Rhino 7. There is Grasshopper for Rhino 7. You can just click this button. Okay. Thank you very much. Thank you, Maglu Chayatom. Sorry if I'm pronouncing your names incorrectly. Thanks, Sasha, for joining. someone asked, let's see, the cleanest curved surface from Oman. Okay, Elmar, thank you very much. Thank you, Aaron, Oliver, Andres, Vignesh, Francisco, thanks guys. How many degrees of curve are used for a class A surface? As less as possible. Okay, if you can model in degree 1 curve, sure, degree 2, degree 3, so the least number of curve degree the better, because you will have less points and you will create cleaner surfaces. Now, of course, it's not practical to create organic shapes with degree 1, so degree 2, degree 3 is common set of curves for a class A surface. Thank you. Currently at a beginner stage in Rhino. Thank you, Dhananjay, for participating. You should teach the left speaker pattern on Grasshopper. Yeah, we do have planned it for the advanced texture workshop. So if you are interested, you should check out that course. All right, so I think we are gonna stop here. Nonetheless, if you have any question, you can write us an email or write to us on Instagram or LinkedIn, and we can help you out with any information. Okay. And yeah, don't forget to share, create variations of the pattern, and share it with us if you want, and we can share it with our social handle. Okay, so we're gonna stop here. Thank you all for joining, and yeah, hope to see you guys in the next webinar. All right, take care, bye.